We have learned about in order, pre-order and post-order. So now let's learn about level order traversal. So basically we need to traverse on level wise. So this is level 0, this is level 1, this is level 2, and for each level we need to print the results over here. So you can see on the first level we have 3, on the second level we have 920, on the third level we have 15 and 7, and this we need to print. Okay, but one more thing we can see, like we are going level by level. So whenever we move from like step by step or level by level, then which approach which technique we can use BFS. So we are going breathwise. Okay. And for BFS, what data structure we generally take? So we take queue. Okay. So basically we push the elements and then pop the first element from the queue, and then we find the relevant children, then we again push it like that. Okay. So how can you identify the end of the current level? So over here you can see for each for level 0 we have printed 3, for level 1 we have printed 920, for level 2 we have printed 15.7, and we for each level we are having a block over here. Okay. So let's find out. Okay, so first we'll have a empty list. Okay, inside that empty list, so this list is for result. Okay, and inside that empty list what we'll have another empty list for this first block. Okay, and we'll be, as we said, like we'll be following BFS over here, so we'll be maintaining a queue. Okay, inside that queue we'll have the root element, which is 3, and we'll have a new line character just to denote if this is the level end /n. We can take whatever we want. Okay, we have taken the queue, but we need to do something with the queue, right? So what we'll do, like we'll run a loop while length of UE greater than 1. Why greater than 1? Because at the end we'll be still be having this special character, right? So in that case, so that we don't fall into an infinite loop, so that's why you have added greater than 1 over here. Okay, next what we'll do, like we'll pop the elements from the queue. So this is the first element in the queue, so as soon as pop it, we'll push into the result in the last block. So currently we have only one block over here, so this element will be popped. Okay, next what is children? So we have 9 and 20. So what we'll do, we'll push into at the last 9 and 20. Okay, then we get /n over here. So as soon as we get /n, what we'll do, we'll put an empty block over here. Okay, and this /n will take it out and we'll push at the last. Okay, now we get 9. So 9 don't have any children, so we'll push into the last block over here. Okay, then so it will be removed from here. Okay, then we have 20 have 15 and 7, so we'll pop it out from here and we'll push it over here 20, and whatever its children we'll push at the last. So 15 7 we'll push at the last. Okay, now again we got a /n over here. So then what we'll do, as soon as get /n, we'll or special character, we'll put an empty block over here, then we'll pop it out and push at the last. Okay, so now we have 15. So 15 does not have any children, so we'll push into the last block. Okay, into the result set. Okay, and then we have 7. So this will be removed, 15 will be removed, 7 we have over here, so 7 will be pushed over here and 7 will be dropped from here. And finally we are having only just /n, and this condition does not satisfy anymore. So this condition does not satisfy anymore and will be out of the loop. So finally we can return this result. Okay, 3, 9, 20, 15 and 7. Okay, so let's try to code this up. So first we'll declare an empty list over here. Okay, then we'll check that if the root is null or not. So if root is none, then return labels. Okay, and next we'll push an empty list, because we need to print like this, list inside list. Okay, so list dot labels dot append an empty list. Okay, next we can declare a queue, because we'll be using BFS over here. So QUE equal to DQ. Okay, DQ, inside that we can append root for now, and then to denote the current level end we can append one more DQEQUE dot append, and we can have a string over here just to denote that whether it's the it is a new line, or it is the label in or not. So I am taking /n over here. Okay, you can take anything. Okay, so then while queue is not empty, now over here we need to see, like, because as we are appending this, right, so every time it will be remaining on the queue. So in this case we can say if length of queue is greater than 1, then only will be popping from the queue, right? Okay, so in that case node would be queue dot pop left. Okay, first we can say, like, if the node is none, okay, then continue, we don't have to do anything. Okay, next, if node we found is node is equal to this /n character, right? So in this case what we have to do, we have to do app. So basically this is denoting like we are almost end of the current level. So in this case what we have to do, we have to add one more empty list. So in this case we can say labels dot append an empty list. Okay, and we need to put this /n to end of the queue. So queue dot append /n. Okay, and then we don't have to do anything, we can simply continue for the next result, next node popping next node. Okay, then we can see, like, if node dot left is not empty, is not none, then we can say, like, queue dot append node dot left. If node dot right is not none, then we can append node dot right. Okay, so this is done. Now over here, if we get if we get a valid node, then in that case we can say, like, else part, we can simply append the result to our current label. So you can say labels length of labels -1 dot append node dot val. Okay, so hope we are good over here. Labels dot append labels, last labels we are putting into the last label, labels dot append node dot val. Okay, so let's try to run this. And finally, okay, I always forget if return labels. Okay, it's passing as well. to submit this. Okay. Okay, so what will be the time complexity for this? So time complexity would be O of n, and space complexity would be O of n. Okay, same. Okay, thank you.